Welding is a very common process in manufacturing, and SolidWorks lets you show welds in your designs in a few different ways. One way to show a weld is to use a weldment part. Here, I have a simple weldment part, and I want to weld the structural member where it joins the plate. To do this, I can launch the fillet bead tool from the weldment's toolbar. The fillet bead tool is a little different than the regular fillet tool. The fillet bead tool is really flexible. You can define gaps and spaces and even specify different properties for each side of the weld by activating the Other Side checkbox at the bottom. To save time, let's just create a simple full-length weld around the entire structural member. Next, we need to define the face sets for the weld. For face set 1, I'll choose one of the outside faces of the structural member. And for face set 2, I'll choose the top face of the plate. When I do, notice the intersecting edges box automatically populates with the virtual edge where they meet. I can weld just this edge, or I can activate the tangent propagation checkbox to have the weld extend around the entire structural member, just like with regular fillets. Let's increase the fillet size so we can see the preview a bit better. The weld looks pretty good, so I'll click OK to finish the feature. This is how you add a weld bead in a part file. I used a weldment part from the start, but you can use the fillet bead tool on any multi-body part. One thing to keep in mind though is that when you add the fillet bead, a weldment feature will automatically be added in the feature manager, and the solid bodies folder will turn into a cut list. Now that we have an idea of how to do this with parts, let's look at how to create weld beads in assemblies. Here, I have a simple assembly consisting of 2 plates. These are just regular SolidWorks part files, not weldments, and they don't have a material specified. The reason I'm mentioning this is that SolidWorks will let you add a weld to parts of any material, but in real life, you don't want to go welding 2 plastic parts together. Even though SolidWorks will let us weld the parts as they are, let's change these parts' materials to steel. The other thing you need to make certain of is that the parts you're welding have at least one coincident edge. I took care of this when I mated the parts. They're both fully defined with 2 coincident mates and an angle mate. Next, I'll go to Insert, Assembly Features, and choose Weld Bead. This brings up a wizard that will automatically create a separate weld bead part file for the assembly. There are tons of options, and you have even more control over the weld in the assembly than you do using the fillet bead in a part file. We could choose fillet again for the type, but let's switch it up. The previews show you the different types of welds available. For this example, let's try a V-groove weld type. I'll click Next. Now we'll specify the surface shape. This governs how the top surface of the weld will appear, and we have the options to use flat, convex, or concave. The preview shows you how it'll look. Finally, this takes us to the mate surfaces. Now, the surfaces you need to specify depend on the type of weld you're trying to create, but you can see from the dialog box that for a V-groove weld type, I need to specify stop faces and contact faces. No top faces are necessary, and that box is grayed out. The contact faces are the faces you want to weld together, these 2 here. The stop faces are used to define the length of the weld. I need to select both the front and back, so I'll select these 4 faces. If we needed to set the top faces, I would use these 2 to let SolidWorks know which direction the top of the weld should be created in. I'll click Next. I can browse for a location to save the part, and give it a name if I'd like, but I'll just click Finish to complete the weld. And there you have it. Now I can create drawings for either of these designs, and the weld bead will appear automatically.